Hello dear students. So today we have learned self-inductance and mutual inductance. So let's study it more vividly and work out few numericals regarding it. So let's move towards the self-inductance concept. So self-inductance. Self-inductance. Okay. The same concept that of Faraday's laws. That means flux linked with a magnetic field if changes, then an induced EMF is produced. And this induced EMF will flow an induced current if the loop is closed. So look at here. Here this is the coil. So this is the coil. When a current is allowed inside it, a current is allowed to flow inside it by connecting with a battery. So if we are making it close, then there is a increase in current. Okay. So how this loop behaves? This loop is like this. What does it mean? That means S. So here south pole is creating and here is north pole. So south to north there will be a magnetic field, right? And this change in current will give rise to the change in flux. And in this way, if current is growing in this way, then another, assume a current will flow and the battery will be assumed like this. And this is nothing but induced current. Are you getting my point? It is induced current. As it is created by the by the same conductor which is causing the effect of change in flux, hence it is called self-inductance. Right? In here, flux change is directly proportional to the current flowing in the conductor. If the current is dying, if the current is increasing, which current? The supplied current. Supplied current is increasing, then induced current will oppose. Induced current will oppose. But if the same current is dying, if the same current is dying, that means decreasing, means when we are making it switch off, then current will be decreased. So to support the current, there will be a battery of this type and the induced current will flow in this direction. Means the current, induced current flows in such a way that we are getting a battery like this system here. So it is not exactly battery, but the current is flowing in this way, in this fashion, that positive charge, positive potential of the battery is in this side and negative potential in this side. So current dying, induced current favors. Induced current favors. Are you all getting my point? Are you all getting my point? Okay, let's move forward. So phi is directly proportional to I. That means flow of current depends on, means depending on the flow of current, flux changes, and thus giving rise to induced EMF. So phi can be equalized by putting a constant called coefficient of self-inductance. L is called coefficient of self-inductance. Understood? Now, if we are moving to the Faraday's law, that means according to the Faraday's law, okay, okay, according to the Faraday's which law? Second law. Faraday's second law. What does it say? It say that induced EMF is nothing but, that is magnitude of induced EMF is nothing but d phi by dt, or in the other way, E is equal to minus d phi by dt, and this negative sign is nothing but signify the direction which is given by Lentz's law, right? So we are concerning about magnitude. So d by dt of Li, right? So L is coming out di by dt. Understood? So EMF is equal to L di by dt, and subjecting L we can get E by di by dt, right? So E is means EMF is volt into second upon ampere, okay, or volt second ampere, which is Henry, it can be written as Henry or 1H. So 1 Henry is the self-inductance of that circuit or of that coil which induces an EMF of 1 volt when a change of 1 ampere per second current occurs inside the circuit, right? And in this way, in the other way, we can also write phi by I is equal to L. That means 1 Henry can be defined as the rate of flux of 1 Weber causes by the flow of 1 ampere of current, right? So this is the SI unit of self-inductance. Understood? Now let's move to the question. So your question is like this. So write it down. There are very beautiful questions are there in your book. So question number 1. The current in self-inductance, L is equal to 40 millihenry. 40 millihenry. Okay. Is to be increased. Uniformly from 1 ampere to 11 ampere in 4 millisecond. 4 millisecond. The EMF induced in the inductor. The EMF induced. The EMF induced in inductor during process. During process is, options are there, bit A 100 volt, okay, bit B 0.4 volt, option C 4.0 volt, option D 440 volt. 440 volt. Okay, so current of self inductance L is equal to this much. So just change the pen color. So L is equal to 40 millihenry. So write it down. L is equal to 40 milli means 10 to the power minus 3. So minus 3 Henry. This is self inductance. Is to be increased uniform from 1 ampere to 11 ampere. That means current is changing from 1 ampere to 11 ampere. So DI. That means 11 minus 1 is 10 ampere by dt. That means 10 ampere per 4 millisecond. Milli means 10 to the minus 3. Okay. Induced, the EMF induced in the inductors. Okay. E is equal to, formula E equal to L di upon dt. Okay. That is equal to 40 into 10 to the power minus 3. Di by dt is equal to 10 upon 4 into 10 to the minus 3. And this 10 to the minus 3 and 10 to the minus cutting cancel out. So 4 10 ja 40. So 10 10 100. So this is 100 volt and the answer is A. Right? Hope you have understood. This is a very easy one. Because a change in current, yet the change in current occurs. This change in current is causing for the induction of EMF in the circuit for the process of self-inductance. Okay, there's a very beautiful question. The next one is very beautiful question. So number 2, to change the color to red for the questions. Okay, so the current, okay, for a coil having L is equal to 2 millihenry. Okay, current flow through it, current flow through it is I equal to T square e to the power minus t. Then the time at which EMF becomes 0, the time at which EMF becomes 0 is, options are there. Option A 2 seconds, option B 1 second, option C 4 seconds, option D 3 seconds. So beautiful questions. So L is 2 millihenry. So let's convert to the black color. Okay, So L is equal to 2 millihenry, means 2 into 10 to the minus 3 Henry. Okay. So I is a time dependent variable. So here we have to do the derivative. That means di by dt. So let's do it first. So as there are two functions, one is algebraic function and another is exponential function. So you can consider as the product rule. So remaining t square as it is, e to the minus e to the minus t is the derivative. Then plus e to the power minus t into 2t. Right. So let's taking common e to the minus t into t. Okay. So remaining is minus t, then plus 2. Right. So the time at which EMF becomes 0. So L is there, something is there. So for EMF to 0, that means di by dt has to be 0. That means t e to the minus t 2 minus t has to be 0. Understood? Okay. Okay. So look at here. There are two conditions: t e to the minus t, t e to the minus t is 0, or 2 minus t is 0. So if t into e to the minus t is 0, then condition something different. That means t is equal to 0 is not possible, because these changes must have happened for a certain amount of time. So e to the minus t can be 0. So e to the minus t is equal to 0. What does it mean? That means 1 by e to the t is equal to infinite. What does it means? Okay, sorry. 1 by e to the minus t is equal to 0. What does it mean? That means t tends to infinite, which is not possible. So next factor can be the answer. So 2 minus t is equal to 0. What does it mean? That means t is equal to 2 seconds. So this is the tricky question of derivative. So 2 seconds is the right answer. Hope you have understood. Okay, very good. Now next part is very graphical questions, which is very interesting and must give you enormous pleasure. Okay, and also it can be asked in the exam. Okay, very good. Let's switch to the question. The current I in a coil varies with time. Varies with time, as shown in the figure. As shown in the figure. Okay. The variation of induced EMF with time would be the variation of induced EMF, variation of induced EMF, variation of induced EMF is EMF with time. EMF with time would be. So what is the figure? Question figure. Let's first do the question figure. Here it is 0. T is the time axis, the x-axis. Then current is the y-axis. So here it is. Okay. So first increases, then declined. Okay, here it is t by 4. So here it is t by 2. And here it is 3t by 4. and then t. So 3t by 4 is this one, and t is the latter part. Okay, here it is 0. So this is the question figure. And what are the answer figure? Answer figure are many. Let's do it. Number A, here it is. So 0 to t by 4. Then t by 2 to t by 3t by 4. T by 2 to 3t by 4. T by 2 to 3t by 4. Okay, and that's t. And here it is time t. And here it is EMF. Okay, the y-axis is EMF and time axis is, this is time axis. Okay, this is A option. B option is like Howrah Bridge. This t by 4, t by 2, 3t by 4, and here is t, and it is t, and here EMF E in the y-axis. Very good. Number C. Okay, the beautiful question. Little bit of analysis, little bit of try wit is needed here. So we have all studied this in calculus part, like in kinematics. You have remembered it in the last year. We have studied it in a very beautiful way. If you can recall it and can do it, then it will be a pleasure. Okay, so here it is t, here it is E, EMF. Okay, on the axis, on the y-axis. The last option, here it is, the positive one, up to t by 4, then t by 2 to 3t by 4. That one is negative part. And next is t. So t, EMF E. Okay. Understood? So let's switch to the question. So what we know, first what we know, what is asking, what is given. Current in the coil varies with time. Where is induced EMF? You are talking about induced EMF. That means E. So we know E is equal to minus d phi by dt. And for current variation, we can also write L is equal to minus di by dt, isn't it? Of course. So here di by dt is the slope. In IT graph, first derivative, that means di by dt will be the slope, and this slope is positive as it is the acute angle. It is making acute angle. Theta 1 is acute angle. So positive slope, that means positive di by dt. If it is positive di by dt, then EMF will be negative, of course, because it is negative here. So EMF will be negative. So when it is positive, EMF is negative. And when it is decline, when it is rest, that means di by dt is 0. That means EMF is 0. So we can make EMF and T graph. What is that? 0 to t by 4, it is negative. And again, t by 2 to 3t by 4, declining means negative. That means a negative slope. Why? Because this is the slope, theta 2, and which is tan 180 minus theta 2. Right? That means minus tan theta. Why? Because it is in second quadrant. And hence the slope is negative, and as the slope is negative, negative, positive, so this part is positive. So in this way we can draw EMF and T graph, and here it is. Answer must be A. Okay, this cannot be possible. This can be possible, but the sign is opposite. Most of the student may choose this one. Okay, but it is wrong. And this cannot be possible. Okay, so let's move to the next part. So now come to mutual inductance. Mutual inductance. So here it is the affair of two peoples. That means one is mutuality, that means one is mutually dealing with the other. That means this is a coil, and here we are making an arrangement of flowing of current, right? So here it is. So this is battery. Okay, and we can also create switch here. Okay, here it is. So now another coil is residing near it, and we can put galvanometer for the detection of current. Right, when we are switch on, that means current linked with the battery is increasing. This circuit is increasing. Increasing means this month's current is flowing in this way. That means it is south pole. So here it is south pole, here it is north pole. So south pole to north pole, there will be change in magnetic flux. Okay, change in magnetic flux. This change in magnetic flux makes the current to flow, that induced current, and induced current direction will be in accordance with the Lenz's law. That means it will oppose. That means magnetic field of this direction, that means along this direction will be formed. And for that reason, here we have to develop what? North pole, and here we have to develop south poles. And for that reason, north pole, that means we have to develop anti-clockwise flow of current. Understood? And for that reason, this anti-clockwise, that means here it is, here it is, here it is, here it is. Can you see it? Like this. Here it is. Okay, here it is. Okay, here it is. Okay, here it is. And here we can get the current of opposite directions. Means here there will be a mutual induction of current. So current direction will be anti-clockwise. That means current will flow in this way. That means this is the direction of current, and battery will be assumed like this. That means it opposes the cause. This is primary coil, this is secondary coil, and all happenings are in front of you. Understood? So EMF in second coil is because of the change in current in first coil. Okay, and here mutual inductance. Similarly, EMF is equal to di2 by dt. So in secondary coil, changes of current results EMF in the primary coil. Understood? And this mutual inductance is same, and it is called reciprocity of mutual inductance. So M is coefficient of mutual inductance. Understood? Okay. So let's move to the question. So let's move to the question. So here it is, the question number. Let's make it red. Question an EMF of 0.5 volt is developed in the secondary coil. In the secondary coil, when current in primary coil changes from 5.0 ampere to 2.0 ampere in 300 millisecond. Calculate the mutual inductance of the two coils. Calculate the mutual inductance of two coils. Options are 0.1 Henry, option 2 0.05 Henry, option C 0.01 Henry, option D 1 Henry. So EMF E2, so write in black or green, so let's use green. So let's wipe out those things. Okay, so like what is there? So E2, that means EMF in E2 is given by MDI1. So प्राइमरी कॉइल में जो करंट का चेंज होगा वही तो EMF सेकेंडरी कॉइल में दिलाएगा, समझ रहे हैं? So E2 is given 0.5 volt, M is asked, okay, and di by dt is given 5 ampere to 2 ampere. That means di by dt is 3 ampere in 300 milliseconds. That means 300 into 10 to the minus 3. That means 100. So 10 to the 2, 10 to the minus 3. So 10 to the minus 1 and 10. So 10 is the di by dt. Understood? So M is equal to 0.5 by 10. That means 0.05 Henry. So this option B will be your answer. Understood? आपको क्या याद रखना है? आपको याद रखना है EMF अगर सेकेंडरी कॉइल में प्रोड्यूस होता है तो चेंज ऑफ करंट प्राइमरी कॉइल में होगा, क्योंकि एक कॉइल में जो चेंजेस होते हैं वही तो लाता है क्या म्यूचुअल इंडक्टेंस का कंसेप्ट। समझ में आ रहा है? वेरी गुड, वेरी फाइन। तो पढ़ाई करते रहिए और आगे भी वीडियो देखते रहिए। ओके, सो तब तक के लिए सब खैर, गुड नाइट, बाय बाय।